Hi students, as a part of UV visible spectroscopy, so today I am going to discuss what are the electronic transitions and what are the possible electronic transitions whenever the UV visible light is passed through the sample. Right. So first and foremost we have to discuss what are the electronic transitions. The name itself suggests that the transition of the electrons from one energy level to another energy level, or the transition of electrons from a ground state to excited state is called as electronic transition. So now let us discuss what are the possible electronic transitions with the help of this particular energy level diagram, or electronic transition diagram, or the figure. So before going to discuss the energy level diagram, so this is the energy level diagram, students. Energy level diagram. So before going to discuss the energy level diagram, I want to recap the molecular orbital theory that among the bonding molecular orbitals and anti-bonding molecular orbitals, bonding molecular orbitals are least energetic when compared to anti-bonding molecular orbitals. And why the bonding molecular orbitals are least energetic when compared to anti-bonding molecular orbitals, I have clearly explained in one of the video which I have made on the molecular orbital theory. Right. Accordingly, as we move up, what will happen to the energy, students? The energy will increase. As we move up, the energy will increase. And these bonding molecular orbitals are separated by the anti-bonding molecular orbitals by the non-bonding line, by the non-bonding molecular orbital. Now whatever the molecular orbital which is associated with least energy is most stable, because energy is inversely proportional to stability. So I clearly explained this also in this particular video. Energy is inversely proportional to stability. Now whatever the molecular orbital which is associated with the least energy will occupy the lowest energy level, students. Will occupy the lowest energy level, that is sigma. That is sigma here. So this is sigma. This is sigma. So next energy level which occupies its place after the most stable energy level or most stable molecular orbital sigma is pi, students. Is pi. Now already we discussed that the bonding molecular orbitals and anti-bonding molecular orbitals are separated by non-bonding line or non-bonding molecular orbital. So next it will be non-bonding molecular orbital, students. Non-bonding molecular orbital, or let us describe with the same color. So non-bonding. Now these two are whatever the molecular orbitals which are occupying their position below the non-bonding line, below the non-bonding molecular orbitals, are bonding molecular orbitals. So these are bonding molecular orbitals. Now whatever the molecular orbitals which occupies their position in the energy level diagram above the non-bonding line or above the non-bonding molecular orbitals or anti-bonding molecular orbitals, students. Anti-bonding molecular orbitals. So the energy is high. So that is, so the next energy or next molecular orbital which occupies its position next to the N non-bonding molecular orbital is pi, students. Is pi. Is pi. Pi. So pi, it is anti-bonding molecular orbital. Since anti-bonding molecular orbital is represented by star, so represent it with star. Represent it with star. Next, the last one which is more energetic. The last molecular orbital which is more energetic is sigma star. Is sigma star, students. Is sigma star. Sigma star. And already I have explained that whatever the molecular orbitals which are occupying their position above the non-bonding molecular orbitals or anti-bonding molecular orbitals, accordingly the pi star and sigma star are anti-bonding molecular orbitals. Anti-bonding molecular orbitals. Right, anti-bonding molecular orbitals, and this is non-bonding molecular orbital. This is non-bonding molecular orbital. Molecular orbital. Right. So coming again, whatever the molecular orbitals which occupies their position below the non-bonding molecular orbitals or bonding molecular orbitals which are sigma and pi in this case, and whatever the molecular orbitals which are occupying their position above the non-bonding molecular orbital or non-bonding line or anti-bonding molecular orbitals which are pi star and sigma star, students. Right. So this is the energy level diagram. Now, what are the expected electronic transitions, students? What are the expected transitions? Electronic transitions. Right. So with respect to sigma, what are the expected electronic? Expected. So with respect to sigma, students, sigma to pi, this is one of the expected electronic transition. Sigma to n, so this is another possible electronic transition with respect to sigma, students. With respect to sigma. Next, sigma to pi star. This is the expected. Keep this in the mind. Sigma to pi star. And another electronic transition which is expected with respect to the sigma is sigma to sigma star. Sigma to sigma star. Students. Now, let us see the expected electronic transitions with respect to pi, students. With respect to pi. So, pi, electronic transition expected is pi n, students. Pi star, students. Pi and sigma star. Pi and sigma star, students. Pi and sigma star. And pi and sigma is not possible, students. Why? Because the transition of electron takes place from one particular level to the next level. The transition of electrons takes place from one particular level to next level, but the transition of electron won't takes place from the particular level to the below level. It won't takes place from the particular level to the below level. The transition of electron is only possible from one particular level to above level. So we have to focus on the above levels with respect to the pi, not the below level. So pi to sigma is not possible. So this is with respect to pi students. Next. These are expected. So with respect to n students, with respect to n. So this is one particular molecular orbital. So with respect to this molecular orbital, what we have to do, electronic transition is only possible from one particular level to the next level, not the below level. So we should not consider n2 pi, n2 sigma. Next level. This is one particular level. The transition is possible from n to pi star and n to sigma star. So n to pi star and n to sigma star. Students. These are the expected possible transitions, electronic transitions. Next, with respect to pi star students. With respect to pi star. So pi star to sigma star. Pi star to sigma star. So sigma star to pi star is not possible. Already I have explained why. What is the reason? Because the transition of electron is only possible from one particular level to the next level, not the level which is below that particular level. Right. Now these are the expected electronic transitions only. But all these electronic transitions are not possible, students. All these electronic transitions are not possible. Now let us see what are the transitions which are possible in the UV visible spectroscopy. What are the electronic transitions possible? So keep this in the mind that the electronic transition takes place when the molecular orbitals are symmetric. The symmetric electronic transition is possible. The electronic transition is only possible between the symmetrical molecular orbitals, sigma with sigma and pi with pi. Accordingly students, symmetrical, sigma with sigma and pi with pi. Accordingly, this particular expected electronic transition is not possible because sigma, pi. So let us talk about sigma n later. Next, sigma pi star. Both are not symmetrical. Sigma, sigma, pi, pi. So this is not possible. Sigma to sigma star, possible. Next, let us talk about the n latron. Next, pi to pi star, symmetric. Next, pi to sigma star, unsymmetric, not possible. Next, pi star to sigma star, not symmetrical, not possible. Now we have to discuss about the n2, the another molecular orbital, n. N means what, students? The non-bonding molecular orbital. So in order to explain the non-bonding molecular orbital, I will discuss one example, which is chloroform, students, What is the group number of chlorine? Chlorine belongs to 7th group. Since it belongs to 7th group, 7 electrons will be a part of it. Out of 7 electrons, 1 is involved in bonding with the carbon and the remaining 6 electrons are there, and these 6 electrons will be in the form of 3 non-bonding pair of electrons. 1, 2, 3, 4, 5, 6. Right. Now, these are non-bonding pair of electrons, students. Non-bonding pair of electrons means what? Non-bonding pair of electrons means these are not participating in the bonding. These are not participating in the bonding means what, students? These are the free electrons. These are the free electrons. Since these are the free electrons, these electrons will move towards the adjacent atom. These electrons will move towards the adjacent atom, that is the carbon. That is, always we know that The transfer of electrons takes place from electron efficient species to electron deficient species. The transfer of electrons is not possible from electron deficient species to electron efficient species. So accordingly it is electron efficient species, chlorine, because non-bonding pair of electrons which are the free electrons. Now the transfer of electrons takes place from non-bonding molecular orbital to sigma, because this is saturated, so sigma. So non-bonding to sigma or non-bonding to pi is possible. That is n to sigma might be possible, or n to sigma, so it is not possible because it is below, right? N to pi is also not possible because it is below. So accordingly we can say that n to pi star is possible because this is the case. This is the case. And n to sigma star, that is the electrons non-bonding pair of electrons are free. Since they are free, they will donate its electrons to the either sigma star molecular orbital of another adjacent atom or pi star anti-bonding molecular orbital of the adjacent atom. That is n to pi star is possible, n to sigma star is possible. So accordingly n to pi star is possible, students. Why? Already I discussed. Free electrons to the adjacent. N to sigma star is possible, students. Right. Now pi to n is not possible because pi is electron deficient when compared to n, which is electron efficient. Always the flow of electrons takes place from electron efficient to electron deficient, not electron deficient to electron efficient. So this is not possible. This is not possible. Now, what are the possible electronic transitions for possible electronic transition after ignoring all these expected electronic transition with the help of the two phenomena? The one is what, students? The one is the electronic transition is only possible between the symmetrical molecular orbital, that is sigma to sigma and pi to pi. And the second one is the electron transfer takes place from a non-bonding pair of electrons to either anti-bonding sigma orbital or anti-bonding pi molecular orbital. So accordingly, so what are the possible electronic transitions, students? The possible electronic transitions are, so this is also not possible, sigma to n is not possible. So sigma to sigma star is possible, right? So n to pi star is possible, n to sigma star is possible, pi to pi star is possible. So now what are the possible electronic transitions which occur during the UV visible spectroscopy, students? That is, whenever the UV visible radiation is passed through the sample, only 4 types of electronic transitions takes place. The one is sigma to sigma star, students. Sigma to sigma star. And the second one is pi to pi star will be there. This is pi to pi star is possible. And the next one is n to pi star is possible, and n to sigma star is possible. That is, only 4 electronic transitions are possible during the UV visible spectroscopy. That is, whenever the UV visible light is passed through the sample. The one is sigma to sigma star, pi to pi star, n to pi star, and n to sigma star. So now let us see. So one possibility is sigma to sigma star. So this is one of the possible electronic transition, students. Next is pi to pi star, students. Pi to pi star. Next, n to pi star. Next, n to sigma star. N2 sigma. Right. Now the energy is more. The energy associated with sigma to sigma star is more when compared to pi star is more when compared to N2 sigma star when compared to N2 pi star. So accordingly, the energy order will be in the following fashion for the 4 possible electronic transitions during the UV visible spectroscopy. That is sigma to sigma star. See, energy is more. Sigma to sigma star is greater than, next, pi to pi star is greater than, next, N2 sigma star, students. N2 sigma star, N2 sigma star, N2 sigma star. Next, these were the possible, but according to the energy, this is order. Next, N2 pi star, N2 pi star, N2 pi star, students. So this is the energy order of the 4 possible electronic transitions in the UV visible spectroscopy. Sigma to sigma star is greater than, pi to pi star is greater than, N2 sigma star is greater than N2 pi star, students. So we have been studying since childhood that the sigma bond is strong and pi bond is weak. What is the reason? This is the reason. So sigma bond is formed by sigma star overlapping, and pi bond is formed by pi star overlapping, students. And the energy of sigma to sigma star is far more than pi to pi star. So since the energy associated with sigma to sigma star is far more than pi to pi star, whatever the bond which is resulted by the sigma to sigma star electronic transition is more strong than pi to pi star electronic transition. And what is the bond which is formed by sigma to sigma star electronic transition? That is sigma bond. And what is the bond which is formed by pi to pi star electronic transition? Pi bond. That is the reason sigma bond is more strong than pi bond, because energy required for breaking the sigma bond is more, because it is formed by sigma to sigma star electronic transition when compared to the pi to pi star electronic transition, which is a part of the pi bond. I hope you understood this topic, students. So expected combinations are so many, but among all the expected electronic transitions, only 4 electronic transitions are possible. The one is sigma to sigma star, the next is pi to pi star, the next is N2 sigma star, and the final one is N2 pi star. And why sigma bond is more strong when compared to the pi bond, already I have explained in this particular video, right? I hope you understood this, right? So if you really like this video, so please do comment on this video. So thanks for watching, students.